Alright, so what we're going to find out on our, really this is the last idea before your next assessment. Okay, again we've got an assessment coming up on Monday of next week, and that is pretty much entitled Solving Equations with Variables on One Side. So that would involve using the multiplicative inverse that we talked about the other day. That would involve solving two-step equations, and then that's also going to involve solving multi-step equations, which is what we're going to focus on today. A bulk of what we are trying to do is if we can get step 1 and step 2 done, then once we get to this level here, we're just solving a two-step equation over and over and over again. Okay? So that's why we spent as much time, even if we didn't need to spend 2 days on that particular section, that's part of why we did, because you got to be able to solve a two-step equation. Alright? Now, I'm going to be honest, for some of us this is going to get a lot trickier because we have to do some simplifying on both sides. And so a couple things. Number one, we need to remember what we talked about in Unit 3. We need to know how to combine like terms, we need to know how to distribute correctly, and we need to be able to do those in the correct order. Alright? Now the other thing is this. I have been big into almost all of my work drawing the line down the equal sign. Okay? This is where students kind of start to make up their own rules, and unfortunately most of the time those own rules are not correct. So, unless I am adding or subtracting a brand new thing to one side of an equation, I don't do one thing to one side and one thing to the other. And you'll see what I mean by this very first example right here. Okay? So, we have 11x plus 8, or sorry, 17x plus 8 minus 11x is equal to 20. And we are asked to solve this equation showing all work. So again, I'm going to start with my line right down the equal sign. And what I'm doing, I'm making sure that I balance stuff out. So step number 1 on your 4-step process. Remember, you should have that worksheet out next to you. Okay? Step number 1 says what? Simplify each side of the equation. Okay? And I specifically put after that, that would include using the distributive property and or combining like terms. What does that mean in this problem?
Combining 7x and 11.
We've got to combine our like terms. Okay? Now, we're not adding or subtracting anything here. Okay? As far as let's add 3 here and add 3 here. We're simply combining like terms. So we're not actually doing an operation on one side of an equation that needs to be done on the other. All we're doing is we're simplifying. So as we did in Unit 3, and I'm going to continue to do it here, let's underline what our like terms are. And remember that we're underlining not just the number, but we're also underlining the sign that is in front of it. So those two are my like terms here. So if I take 17x and a negative 11x, because there's a subtraction in front of that, and I add those two together, what do I get? I'm going to get 6x. These two terms here are going to combine to give me 6x. Now, I still have my plus 8 that I'd still had before, and now that's equal to 20. So some people go, well, but you added 11x, so shouldn't you add 11x on the other? No, we didn't add 11x. We simply combined like terms. So, yes, the numbers changed, but they changed because we combined them. Okay? So, now, what are you left with? A two-step equation. Okay, we're going to try to get to everybody today. Caitlin, starting in the back right. What are we going to do after this? Okay, now we physically have to subtract 8 to get rid of that. And if we're subtracting 8 from the left-hand side, that does require us to subtract 8 from the right-hand side. Okay, Chloe, after I subtract 8 from each side, what do I have on the left-hand side? These cancel, but what do I still have left? I still have my 6x. Quentin, what do I have on the right-hand side?
12.
I've got 12, because 20 minus 8 is going to give us 12. Okay? Cynthia, what are we going to do next, then, as our step to solve this for x? We're going to divide each side by 6. Okay? So, Miguel, when I take 6x and I divide by 6, what are we going to have on that left-hand side? We're going to have 1x. Okay, and Miles, on the other side, when I take 12 divided by 6, we're going to be left with 2. Okay? Now, here is the big thing. Like, check your answer. Here's the problem, though. If you go back and you check your answer into this equation, 6x plus 8 equals 20, you're going to find out if you've solved that equation correctly. But you're not going to find out if you simplified it correctly. So what I always tell students is if you're going to take the time, you need a new packet here. Okay? If you're going to take the time to check your work, you need to go back into the original equation and plug it in. Not back into what you think you now simplified it to be. You need to plug it back into the original equation. Alright, so let me show you what that looks like here in just a moment. You know how to get it for? Yeah, so it should be in there, right? Keep going. Keep going. Keep going. One more. A lot. Alright, so here's what I mean by that. If I'm going to check this problem, then I need to take this entire equation here and show that. So I'm going to take 17 times your x value, which is 2, plus 8 minus 11 times your x value of 2. Now, I'm not asking you to evaluate an expression and testing you on that, so I'm fine if you do more than one step at once. What's 17 times 2? 34. Bring down my plus 8 minus, what's 11 times 2? Okay, take that into your calculator. What's 34 plus 8 minus 22? This gives me 20. That's where you should be checking your answer. Again, don't plug it into the simplified portion of it. Plug it back into the original answer. That's what's actually going to show you if it's going to be right or not. You could. If you type that whole thing into your calculator and your calculator follows the order of operations, which it should, you're going to be able to just hit enter and your calculator is going to give you 20. Great question. Alright, let's take a look at example 1b. Maya, where are we going to begin? Can we simplify the left-hand side at all? No. Okay. Maya, can we simplify the right-hand side at all? Yes. What two terms can we combine together? Alright, this is a negative 3y and this is a positive 8y. So Maya, if I take negative 3y's and I add 8y's, what are we going to get? We're going to get 5. So this now becomes 5y. Then this is still a minus 10 because there's a subtraction in front of there. Okay, and again, now at this point, we're down to solve our two-step equation. Okay, Emma, what are we going to do next? We want to work on getting this variable by itself, so we need to get rid of that. How do we undo subtraction? Okay, so what do we got to add to both sides? What's being subtracted? 10. Okay, so what do we need to add? 10. Yes. Add 10 to add 10. Rollin, what's that give me on the left-hand side? 30. What, Rollin, what's that give me on the right-hand side?
It gives you 5y.
Just our 5y, because our minus 10 plus 10 cancel each other out. Okay? Quan, what do we do after that? Okay, we need to undo our multiplication with division, so we need to divide by 5. So divide by 5, divide by 5. Abby, what's 30 divided by 5 going to turn out to be? Okay, and on the other side, when I take 5y divided by 5, we're going to be left with y. Okay? Or 1y. But as we've talked about for a long time, we're not worried about putting that 1 there. We're just putting y as my final answer.
Like, if you put y equals 6, is it the same thing?
Yes, it is.
I'm a bit lost with this. How did we get 5 again?
Okay, because we took our negative 3y that's in the original. We took our 8y. And if I take negative 3 and add 8, we're going to get a positive 5.
Alright, I was just asking.
Yep. Alright, now let's scroll down to C and D. So, the same idea. Simplifying can take on a lot of different forms. We need to simplify letter C before we can start to solve it. Hayden, what do they mean by simplifying this problem? They're going to tell us to distribute. So Hayden, when I distribute here, what are we going to get? Negative 24 equals what? 12 and what? Negative, so 12 minus 6b. Okay, remember that if you multiply through by a positive, which is what we're doing, the signs inside the parentheses should not be changing. Okay? Alright, Chloe, tell me where we're going to go after that. We're going to subtract 12 from both sides. Exactly, that is a positive 12, so we need to subtract 12 from each side there. Okay? Subtract 12, subtract 12. Kane, what's that mean my new equation is going to look like?
Negative 6b equals negative 36.
There we go. We've got negative 36 on the left-hand side. We've got a negative 6b on the right-hand side. Clara, where do we go from there? We would by what? By what? By what? What's b being multiplied by? Look at that right here. What's b being multiplied by? Okay, so what do we got to divide by? Negative 6. Not just by 6, but also by that negative 6 to get rid of it. Okay, Megan, on the left-hand side, we're going to be left with what?
Oh, sorry.
On the left-hand side, what's a negative divided by a negative?
Positive 36.
Positive 6. And on the right-hand side, we're going to be left with what, Megan? Just left with b. Now again, I'm just going to show it this one time, and then you guys will be able to do it from here. This is what it would look like typed into your calculator. You're going to need to make sure that you use parentheses, because those parentheses are a big deal there. So when I type that in, if I take 6 times and then use parentheses 2 minus 6, your calculator should spit out and give you that final answer of negative 24, which is what it should be. Alright. Let's see where we left off at. Bryce, have you gone yet?
No.
Alright, so tell me, Bryce, where are we going to start in example D?
Well, for one, we're going to start with multiplication to get rid of negative 2 times 7 and negative 2 times 4.
Alright, now, here's one thing to remember. We're multiplying through by a negative, which tells us what? Signs are going to flip. Okay, so Monica, what are we going to have when I distribute here? Negative what? Negative 14, and then what? Plus 8a equals 10. So again, notice that the first number went from being positive to negative. My subtraction went from a subtraction to a plus. Okay, Francisco, I need to know what I'm going to do next to solve for D. What's that? Plus what? Plus 14? Okay, so we're going to add 14 here. We're going to add 14 here. Evan, when I add 14 to both sides, what's the new equation look like? What do I have on the left-hand side here? Well, but not a negative 8. Remember, we changed our sign, so this was a plus 8, right? Delaney, Evan's answering it. She's got it. So we've canceled the 14s, right?
Yeah.
So we're left with what on that side? 8a. And on the other side, what do we have? 24. Delaney, where do we go from there?
Divide by 8.
Divide each side by 8. Caitlin, we divided each side by 8, so what do I have on the left-hand side? A, and on the right-hand side? 3. A should be equal to 3. And again, I ask what we have because sometimes that's the biggest error we make. Like, we know the operations we're supposed to do, but our simplifying is still maybe not as strong as it should be. So that's why I always want to make sure that we understand what that next line is. I don't just want to show it. I want to make sure we understand why it is what it is. All right. Questions on example D? Okay. Now, letter E. Simplifying this particular problem is going to tell us to be doing what? Distribute and combine by terms. Now, I was mean back in unit number 3 and gave you some hard ones like this because I knew they were coming up here in unit number 4. Chloe H., what are we distributing through here? So in letter E, we've got to begin by distributing, correct? What are we distributing? Exactly. It's a -4. It's not a +4. Why do we know we're distributing through a -4? Because there's a minus sign in front of it. So if we're distributing through a negative, that's going to tell us the signs inside of this are going to change. So Quentin, after we've distributed, what's this left-hand side going to look like? Equals 14. Perfect. So my m that was positive became a negative, and my 1 that was negative became a plus. Cynthia, what do we do from there?
No. When you add,
Are we done simplifying?
no,
Okay, so what do we need to still combine?
go for this and
Alright, so we have a 6m and we have a -4m that need to be put together. So when I put those two together, what do we get? We get 2m. So I have 2m plus 4 equals 14. Miguel, where do I go next? We have to get rid of the addition. How do we get rid of addition? So what do we got to subtract from both sides? Nope, we want to get the variable by itself. 14's already on the other side. We still need to get rid of what's being added. So what do we need to subtract? Subtract 4. Maya, if I subtract 4 from both sides, what do I have on the left-hand side then? Not just m, but we still have 2m, and on the other side we have what? (14 minus 4 is 10. I think you added. Okay? Miles, what do we do next?
Divide.
Okay, by?
2.
Divide by 2. Roland, what do I get when I divide by 2 on the left-hand side? M, and on the right-hand side? 5. Again, you could type this into your calculator like this. 6 times 5 minus 4, and then in parentheses, 5 minus 1. And make sure that when your calculator gives you that final answer, that it does actually give you 14. Delaney, question?
No.
Yeah, go ahead. Ask, please.
Like, I don't know what to do with the negative and positive signs for the 4. Like, when you change it,
Like here or here?
like in the beginning.
Okay?
You like, keep getting switched back and forth.
So, first of all, you understand that we multiplied by a negative, right?
Yeah.
So anytime we multiply by a negative, sign should be changing after I've distributed, right?
Yeah.
So this m, which originally was a positive m, became a subtraction problem. And I just took 4 times 1 to get 4. Then this subtraction is going to change to become a plus, and 4 times 1 is 4 again. Does that make sense?
Yeah.
Okay. All right. Let's jump to F. Emma, where are we going to begin? Okay, so what do we got to do? What do we call that? Starts with a D. distribute. Now is it a 2 or a negative 2? I'm just asking. Pay attention to the sign that's in front. It is a negative 2. So we're distributing through a negative 2 here. All right. Daquan, what do we have then? 30 equals what? We're going to distribute through that negative 2. Tell me what I'm going to write down here in my next step. Okay, but hold on. What's the very first thing we still pull down? Okay, so we have 5p. Now tell me what I'm writing. I just want you to distribute. That's it. Okay, except this is a negative 2, right? Are we okay over there? So negative 2p, yep. And then what? Plus or minus? Which one? Plus 6. Because again, this negative is going to change the signs on each of those. Abby, what do we do after that?
So then after you do that, you add theta to not add, subtract the two terms.
Okay, so what's my next equation look like then, Abby, when I go to write this down?
Equals 3p plus 6.
Perfect. Chloe, where do we go from there? Minus 6 from both sides. Hayden, what's that give us? 24 equals what? 24 equals, what's the other side of the equation? Well, 30 minus 6 is 24. I don't know what I'm writing over here yet until you tell me. Not P. 3P. Evan, where do we go from there? What do you mean 3 on both sides? Add, subtract, multiply, divide by it. Stop looking at Delaney. Okay, how is the 3 and the P right now attached? Those are attached with multiplication right now, so we need to what? Need to divide. Delaney, what's that give me on the left-hand side? 8, and on the right-hand side? P. P should be equal to 8. I can tell you right now, this would be a very good way to see level 1, level 2, level 3 when we start talking about these types of problems. All right. Everybody got that copy down because we got to flip it over and take a look at story problems, which I know is everybody's favorite. All right, so here's what I'm going to tell you right now. This is, again, a good reason on why you need to have a process on what to do, because there are several numbers in this particular problem, and we got to figure out which ones, if any, get variables and how they all go together. So, a group of 5 friends are going to a baseball game. There are exactly 5 of them. Okay? Tickets for the game cost $60 for the group. Not individually, $60 for the group. Hot dogs cost $2.75 each and bottled water cost $1.25 each. Write and solve an equation to determine how many hot dogs and bottles of water they can buy if they buy the same amount of each of them and have a budget of $88. So, let's start with this. What are we looking for? How much of hot dogs and waters they can buy. Not the cost, because we already know the cost. Okay? So, we're going to let X equal the number of hot dogs / bottles of water. Because it tells us that we're spending or we're buying the same amount of each. Now, again, for some of us to kind of get used to this, I'm going to write this additional piece in here. Let's talk about what we all know is going into this problem. Okay? What are these guys all buying? Well, what's the very first thing they bought?
They bought tickets.
They had to buy tickets. Can't get into the game unless you got a ticket. Okay? Now, from tickets, they're adding in what? Hot dogs and bottles of water. So we're going to add in our hot dogs. We're going to add in our water. Are they buying anything else? No, so this is equal to our total, everything that we are spending. Okay, does that make sense to everybody there to begin with? Again, this is not expected to be shown on every assessment, but I'll be honest, this is what many of you are thinking on this particular question. We're just writing it out so you can start to piece it together. Now, let's start plugging in numbers that we know. First of all, how much were tickets? $60. Is that for all the tickets or several or one? All. So is this a one-time fee or repeating fee?
One time.
Tells us what? No variable. All right, what do we know about hot dogs?
$1.
$2.75 each. Is that a one-time fee or repeating fee? So that tells me we should have a variable with it. What do we know about water? It's $1.25 each. One-time fee or repeating fee? Repeating fee. That should have a variable on it. So my tickets plus my hot dogs plus my water should equal our total. And how much are we spending? $88. All right. You guys got 2 minutes. Solve. Again, following that same process, we're looking to simplify. That could be distribute, combine like terms, or both. And then from there, solve that two-step equation. Alright, so let's take a look. What do we need to do first? Combine like terms. There's no distributing or anything else. We are taking this term here, and we're taking this term here, both with our variables, and we're adding those together. So I'm just going to bring down the 60. Okay? Keep that there. What is 2.75 plus $1.25? $4. Okay? So pretty much, when we buy a hot dog and a bottle of water, we're automatically paying $4 total. Okay? So this 4 now has the variable of x on it. This is equal to 88 then. And again, as I talked about, once you've simplified, you're down to a two-step equation from here. Okay? Monica, what are we going to do next? Alright, we're going to go ahead and subtract $60 from both sides. That's how much money they spent on the tickets. That gives us 4 times x is equal to 28. So really what we're saying is they got 28 bucks to spend on food and drinks. Okay, Francisco, what are we doing then to solve for x? What's that? Divide by what? Divide by 4, exactly. So we divide by 4, and we divide by 4. And what we find out is they can spend a total of, or they can buy a total of 7 hot dogs and waters. All right, questions on that? Okay, I'm not going to give you long, but I want to see before I show you how to set up 2B, can you set up 2B? So I'm only going to give you about a 90-second head start here, because I do want to make sure I get through all of this before we leave. Tell me what x is, if that's the variable that you're using. Alright, so I'm going to go ahead and start getting through this so I can make sure that we are done when we leave here with complete notes. So I let X represent the number of tickets. Here's, as we read through this story problem, what it's telling us. We have a price per ticket, we have a convenience fee, and we have a processing fee. And all of this together is equal to our total. So, what do we know about the cost of each ticket?
$35.50.
Nope. $32.50. There we go. Is this a one-time fee or repeating fee? Repeating fee. Every ticket I buy, get charged an extra $32.50. I got to throw a variable on there. Okay. Convenience charge. How much? $3.30. One-time fee or repeating fee? Repeating fee. Every ticket I buy costs an extra $3.30 for the quote-unquote convenience charge. It's convenient that they charge that. Processing fee is what? $5.90. Is this for every ticket or just once? Just once, so no variable. Equals a total of $220.70. Where do we begin? Combine like terms. We have a per ticket cost and a convenience charge cost. So really, when you buy a ticket, you're not paying $32.50. Really, every time you buy a ticket, you are paying how much? $35.80. Okay, plus $5.90 equals $220.70. Again, now we're down to solve your two-step equation. Undo addition with subtraction. That means that $35.80 times X is equal to, what is that, $214.80?
Yeah.
That sound right?
Yeah.
Then undo multiplication with division. Divide by 3580. And we get X to be 6. So,
6 tickets.
6 tickets. Yep. This particular person has ordered a total of 6 tickets if that was their final cost. Alright. Assignment for tonight is going to be page 127. Numbers 1 through 31 odd. Let's make sure that this is done for tomorrow. Okay, not partially done, didn't even look at it. This is done, so this is what our discussion is about during third period.